Okay, so suppose I had this piecewise function, f of x equal, and let's say this piecewise function, the first one is 3x minus 2 if x is less than, let's say, 4, and then negative 3 if x is greater than equal to 4. And so suppose I want to find a f of, let's say, 6. All right, so if I want to find f of 6, now this was from last week. If I want to find f of 6, how do I find f of 6? Well, first of all, you got to determine which function you're going to use. Which part of this piecewise function is going to apply here? The bottom one, because x is 6, and this is the part of the domain where 6 is greater than equal to 4. So you have to use this one. So the question is, what is the y value when x is 6? Well, some of you still have a little issue here because there's no variable for this part. Well, that means that y always equals what? Negative 3 whenever x is greater than equal to 4. So if x is 8, what's y? Negative 3. If x is 9.2, what's y? Negative 3. Okay, so that's negative 3. And then the b part, what is f of 4? Which one do I use for that one? The top one or the bottom one? The bottom one, because that's the one where that says that x can also be what? 4. And then C, what if I want to find f of, let's say, negative 2? Which one do I use? The top one, because that's the one that says I use this whenever x is less than 4. Well, negative 2 is less than 4. So now here I do have a variable, so I'm going to say 3 times negative 2 minus 2, and then 3 times negative 2 is a negative 6, and a negative 6 and negative 2 is a negative 8. Okay? All right, so that was a quick review from last week. Now let's go ahead for this part. Now let's go ahead and start graphing this. All right, so let's graph. Let's say we had this one, f of x is equal to, let's say, x plus 4 if x is less than 2, and then negative 5 if x is greater than equal to 2. All right, so you're going to need graph paper for this. All right, so you're going to graph these in parts. So you're going to graph the top part of the function first, and then you graph the bottom part of the function second. Okay. Now the top portion, I only when I use a t-table, you can use the idea of a t-table. So I'm going to say top part, and my top part's this. I'm going to say y equals x plus 4. Okay. Y equals x plus 4. So break it down like this, and you're going to use a t-table. All right, listen carefully. The domain that's associated with the top part is any number that's less than what? 2. Okay? So like 1.99, I can use 1.99, couldn't I? 1.99999, and so on, right? So I can pick any number that's very, very close to what? 2. Now, I am going to use 2. Now, we're going to discuss how to deal with that. Is 2 part of this domain? No, because there's no equal sign. Is 2 part of this domain? Yes. So you're going to see the differences between these two when you plot those points. But whatever number's used here, you're going to use in both parts of the function. Okay? So if x is 2, you're going to say 2 plus 4 is what? Is 6. Okay? Now, if you notice y equals x plus 6, isn't that a line? That's a line, right? And to graph a line, how many points do you need? 2. So I need one more. So give me one more x value that's in this part of the domain. Negative 1. If x is negative 1, I get negative 1 plus 4, which is what? 3. All right, now here's how you graph this. Okay, Now remember, the domain is not all real numbers, right? The domain for this function is from negative infinity to what number? 2. I'm going to write it like this. Negative infinity to 2 with parentheses or brackets? Parentheses, because there's no equal sign. All right, so that's what this means right here. This right here is the same thing as this. So when I graph this, I'm going to plot the point 2, 6. So plot the point 2, 6 right here. Now, don't do it just yet. Is 2, 6, is x equal to part of my domain for the top portion? Yes or no? No, because why? There's no equal sign. So since it's not part of the domain, you're going to use an open circle. That's where we start using open circles. So use an open circle. So 2, 6, you have an open circle right here. Just kind of make it look like an open circle. Okay? And then we'll plot the point. What was the other point we found? Negative 1, 3? Is negative 1, 3 part of the graph? Yes, because negative 1 is in the domain. So negative 1, 3 is here. So notice I put a dot, not an open circle, a dot. And then all you do is draw. Now this is not a line, because remember, a line has 2 arrows. It's a ray. So you're going to do this. Just like that. Okay? So notice that this right here is this part of my piecewise function, x plus 4. All right, so I'm going from negative infinity all the way to what y value? To what x value, excuse me. 2 with an open circle. Why is this an open circle? Because there's no equal sign here. So 2 is not part of the domain for this top portion. Okay? All right. Now, we did the top portion. What part do I do now? The bottom. All right, so I'm going to write it. I'm going to say bottom part. I'm going to say y equals what? Y doesn't equal 3. Y equals what? Negative 5. Okay, y equals negative 5. Now, you graphed things like this in the previous course. This is also a line, but there's no variable, right? So that means that y always equals what? Negative 5. No matter what x is. But I'm restricting my domain for this. I can only use which values for x? Any number greater than or equal to 2. So when I do my t-table, remember we say we have to always use this number that you see here, right? I'm going to say 2. When x is 2, what's my y value? Negative 5. All right, now this is a line. I need one more value for x. Give me another value for x. That's in here now.
1.
1's not in here. Why'd you say 1? Tell me why you say 1. Is 1 greater than or equal to 2?
No.
No. Why would you say 1?
Because I read it as less than. I was looking at the top one.
Okay. All right. So, what'd you say?
4.
Okay, you want to use 4? That's fine. If x is 4, what's my y value? Negative 5. All right, so let's discuss how to plot that, how to graph this. All right, so I found 2 points. What's the first point? 2, negative 5. Now, when I plot that point, 2, negative 5, right here, when I plot that point, is that going to be an open or closed circle? Closed, because there's an equal sign. 2 is part of my domain. Oh, you're right. Thank you. 2, negative 5. Yep. So 2, negative 5 is right here, right? So it's not 2, 5. It was 2 what? Negative 5. So make sure you erase that. All right, I need one more point. What was the other point we did? 4, negative 5, right here. All right, now I got to graph this. Now, some students have a little issue graphing this because they want to, here's what they do. And I want you to visualize this. I'm going to go ahead and put this in a pencil so I can erase it. And then let's see what we get. This is what they do. Some students, they'll do this like that. For one thing, it cannot be correct, right? Because it fails the vertical line test. This is a what? a function. So don't do anything like this when you realize, hey, for this x value, there are two y values. I did something wrong, right? So you know we cannot do that. The other thing, the other reason you know that this cannot be correct is because you're saying that I can use any of these numbers for x right here. But the smallest number I can use for x is what number? 4. So that's just right here. Oh, I'm doing the wrong one? I'm sorry. 2, right? 2. Okay? So I got to erase this part. And so it's actually going to be here. So you're going from 2, x equal 2, to any x value to the right of it with an arrow. Don't forget to draw an arrow. So that's your graph. That's the graph of the piecewise function. This piecewise function had how many parts? 2. You better see how many parts? 2 on your graph. Okay? All right, let's do one more with this. And then that should help you with the back part of that worksheet. So let's do this one. Let's look at part B. So for part B, go ahead and use this piecewise function. F of x equal 2x minus 1 if x is less than negative 2. And then x my x plus 1 if x is greater than or equal to negative 2. So let's graph this one. All right, so I'm going to graph this piecewise function. Okay, so you do it in parts. You do it in parts. So let's do the top part. Remember, f of x means the same thing as y. So you can say y equals, and what does y equal over here? 2x minus 1. So y equals 2x minus 1. Again, that's still a line, but you're not going to draw 2 arrows like you normally would because your domains are restricted for each part. When I do a t-table, I need to use these x values right here that you see. So I'm going to use what x value here to start off with? Negative 2. Okay? Now when x is negative 2, I'm going to go back to this function right here, to this equation, and where we see an x, I'm going to substitute negative 2. So I get y equals 2 times negative 2 minus 1. What's negative 2 minus 2 times negative 2 minus 1? So it'll be negative 5. All right. Now, remember, to graph these lines, and these are lines here, but when we graph them, they'll be raised. To graph this, I need one more point. So give me another x value that's in here, though, now. Negative 4. Okay, if x is negative 4, I get y equals 2 times negative 4 minus 1. So that's negative 8 minus 1, which is negative 9. All right, so those are the 2 points I'm going to use to graph this piecewise function, or this part of the piecewise function. All right, now we're gonna plot those points. Now remember, that's where you have to look at your restrictions. Is it included or is it not included? That's the question. So when I plot the point negative 2, negative 5, which is right here, am I going to put an open circle, closed circle, and why? An open circle, because when I found the y value for x is negative 2, is negative 2 part of this domain? No, because negative 2 is not less than negative 2. Negative 2 what? Equals negative 2. Okay? So this is going to be an open circle right here. That point's going to be open. So I'm going to do negative 2, negative 5 open right here. Now I need one more point. What was the other point I did?
Negative 4, negative 9.
Now is that going to be open or closed? They'll be closed because when x is negative 4, is that part of the domain? Yes. Negative 4 is less than negative 2. So negative 4, negative 9 is right here. So you put a dot, and then you draw your ray. Now be careful. Am I gonna draw a line that goes through those 2 points? Yes or no?
No.
No. I'm going to draw a ray that starts here with the open circle and then goes down like this. So that is that part of the piecewise function. And then we do the bottom part now. So the bottom part of the piecewise function, so break it down into parts. This time I'm saying y equals what? X plus 1. All right, I'm going to do a t-table. Again, this is still a line. Y equals x plus 1 is a line, although when I graph it, it'll be a ray because I'm restricting my domain. Again, what x value must I use here? Negative 2. Whatever this x value that you see here, except one's going to be open, one's going to be closed. If x is negative 2, I get y equals negative 2 plus 1, which is what? Negative 1. Now I need one more point to graph y equals x plus 1. So I have to use an x value that's what? Greater than or equal to negative 2. So give me an x value. 3, 0. Let's use 0. If x is 0, I get y equals 0 plus 1, which is 1. If you use 3, you'd say y equals 3 plus 1, which is 4. Okay? So then I plot those 2 points. Now, you remember for whatever this x value is here, whatever that number is here, when you plot that point, one's going to be open, this one will be open, this one will be what? Closed. So this point here is going to be closed, not open, like this one was. So I plot the point negative 2, negative 1, negative 2, negative 1, which is here. Closed, right? And then I plot the other point, which we said was 3, 4, which is here. All right, now remember, most students can get this without messing up, but there's always a few that will, when connecting those 2 points, will draw a line. Is that correct? No. You got to start here and then go what? Go up like this with an arrow. All right, so there's your graph. All right, that's all you did with those. So if you look on that back page of that worksheet, the one that was 2.2 part 2, look on the back page, that should be enough. I did one like number 5 and I did one like number 6. When using the t-table, you're going to use what value for x for both of those? For the first one, 2, and for the bottom, you're going to have to use for negative 1 for both of them. Okay. All right. Okay. So see what you can do with those at some point. All right. So that was how to graph a piecewise function. Okay.